So now moving on, let us welcome our next presenter on stage, and please help me welcome with a big round of applause Mr. Ram Mohan Mutharasu, Product Specialist, Food Safety and Quality from bioMérieux, India. Ram, welcome to the stage. And Ram would be addressing you on addressing the food safety challenges, augmented diagnostics, AGDX approach. Ram, all over to you.
So, very good morning, everyone. I hope my voice is audible at the last, no? Hello? Is it audible now? Yes, thank you so much. So, very good morning, everyone. I would like to thank each and everyone for being here. And it's been a pleasure to me to give a brief introduction on the augmented diagnostic approach. And I would like to thank the panel which happened very the last. I mean, they have actually set the pace actually. Like talking about the frontiers in food safety and innovations in testing. So this is in line with that, and I think almost half of the points that they have discussed, I can vouch on it, and I can able to give a brief information on how, as a kind of say as a solution provider, we can provide you the augmented diagnostics in a simple, easy, and also in a seamless way. That's a brief about it. And yes, so this is something that I mean, I would not say as a challenge, even it's a challenge and also opportunity to some extent. Let's say like today, we talk a lot about innovation, and also we say like we spend a lot of time in talking about the quality, right? And also the time that we spend most of the time in talking about something which is non-quality. Let's say the sourcing, starting from raw material procurement, we spend a lot of time. So challenge associated from the raw milk till the finished good production and also till the supply and it reaches the fork, we have lot of issues, right? So one of the key issue in that which I would like to highlight is food safety. That's what we also been here. And also one more thing is that food industry right now is at a turning point because they have to give innovative product to the customer. They also have to ensure that the product is safe and it is of good quality. And also customer retention, loyalty, there are a lot of stuff which is associated. So, as I said, like food safety is the main priority that I'm going to talk about. I would like to give more focus into the microbiological food safety. And one of it is that what are the microbial challenges that we have in food industry. So let's say, for example, here I have mentioned one is pathogen and spoilage and quality indicators, they both can be clubbed together. So pathogen contributes to 20% of the current testing in terms of food industry is concerned, and 80% of them is being quality or ID indicators. Let's say for pathogen is something, yes, if it is consumed, it is going to harm me, and it is very lethal also. So why pathogen testing is most important is that because it will ensure like I am providing a food which is safe, so consumer protection is there, and at most is a regulatory requirement, and also brand image is also at the stake. And next, in terms of spoilers and quality indicators, let's say spoilers is something maybe it will not be, I mean, it will affect the organoleptic properties. So the consumer acceptance is going to deteriorate. It is going to impact the brand image. And also, if you see that number of recalls may happen because they say like, yeah, it's not of the good quality which customer intends to use. So a lot of costs is associated to it as well. And next is the quality indicators. Quality indicators can be a tool for us to assess whether good hygienic practices followed, good manufacturing practices followed, and also it can also be an indication for us to understand if there is any pathogenic contamination is there, or even if there is any fecal contamination is there. So that's what is something is there. And next, if let's say for example, if quality indicator is there, we can ensure that we can say like hygiene is not at the right level, failure of hygiene is there. Again, we can say like probability of pathogen or spoilage is there. Yes, these are regulatory requirement also. I would like to give more focus into spoilers followed by pathogen because spoilers is something we say like maybe I have mentioned here no health risk, possibility of health risk is still there. So majority of the spoilers, let's say for example bacteria for juices, it is 𝑰𝒏𝒂 it will change the quality, it will check the organoleptic property of juice, right? And again Pseudomonas, for example milk, it is one of the major contaminant in milk. And also yeast, Brettanomyces saccharomyces, which is let's say predominantly found in beer, wine, and also let's say in fermented milk products, and mold, right? Before that, I mean before I move into augmented diagnostics, I would like to give a brief about who we are. because as I say, like I'm going to give more focus into microbiological food safety. So we bioMérieux actually follow Pasteur tradition because the founder of bioMérieux, I mean, Chairman of bioMérieux actually is the student and co-worker of Louis Pasteur. So we have 125 years of experience completely into the field of microbiology. So bioMérieux actually is founded in the year of 1963. So we have 60 years in the name of bioMérieux, but the group company is almost 125 years old. So bioMérieux actually is a French biotech company. So we provide innovative solutions which is in the in vitro diagnostics. So which is providing you simple, easier, and more importantly faster result. If I say faster result, the next term is like whether it is accurate. So all the solution which is provided by bioMérieux is of global standard and is also been accredited, I mean validated and accredited by a lot of renowned food agencies like AFNOR, AOSC, Microval. Even we have certifications from FSSA under the scheme of PRAP as well. So coming to the main topic, augmented diagnostics. Yes. So if I say augmented diagnostic, it is like, let's say, for example, you have mentioned about advanced microbiology. It can be a conventional microbiology as well, provided that we have data points, we have the historic data. So it's a combination of microbiology, molecular biology, genomics, and data science. So this is not something new. This is like we can say it's a evolving philosophy. It is actually evolving the philosophy of safety because this is going to provide you a big data. With this data, you will have a let's say a better decision making capability, and also you can able to take a decision at the faster time, right? And next thing is that this will help you to give let's say provide you a risk assessment, and also it will able to provide a quality control automation which is very useful in terms of big data. And this data will provide you insightful actions in terms of the total, let's say not only in terms of manufacturing but the entire plant area as such. And this is the, let's say, for example, as I said, like we provide a, rapid solution. So these are the full automated solutions that we have. So how we actually do the augmentation with it. So let's say, for example, we have pathogen detection name which is 𝑰𝒏𝒅𝒂. So this is one of the kind of, let's say, is used by many of the food testing labs right now by enable laboratories. Even FSA labs also, accredited labs also utilize this platform for pathogen detection, right? And we also have a platform named 𝒏𝒏𝒅𝒂, which is the simplest real-time PCR platform globally, I can say. So we are actually clubbing the data collected, and we are actually augmenting. When I say augmenting, it is from the molecular biology and also the data that we have obtained from this testing. That's the entire approach. So it will actually provide you an insight, actually what's the real scenario behind the food testing and what's happening in the industry also. So I will just give a brief let's say, for example, I will just give you a brief information on how augmented diagnostics can help dairy industry. For example, let's say UHT, right? So UHT, as the last panel also discussed, like we have to do something from the start, starting from the raw material, in process, finished product. But the thing is that we know milk is a perishable nature, yes, but UHT, we are extending the shelf life of the product. But the time to result or time to release the product is the major concern or the pain area for the dairy industries, right? So if there is any solution which is available in the market, which can provide you a rapid result and also a real-time result without any incubation. Let's say, for example, so with the help of decount flow cytometry system, you can able to enumerate the live cell, not the dead cell. I cell without any incubation, you can able to enumerate the number of live bacteria. So it will give you a kind of information like, okay, my raw milk quality is this much. So higher the quality of the initial, I mean the raw material, higher is the quality of the finished product. So we can able to enumerate. That's why I say like the time to result is actually 1 hour, and the sensitivity, let's say without any incubation, you can able to detect 10 to the power of 2 and 10 to the power of 3 bacteria, yeast and mold put together, right? And next is the finished product testing. So in finished product, let's say for UHT right now, we as per the IS standard, we incubate the milk for 7 days. So after 7 days, we check for the pH changes. If I am following Codex Alimentarius Commission guidelines, RCP protocol, then I have to incubate the milk sample for 15 days. So I have huge gap. After that only I can able to release the product. But with this application, let's say minimum 24 hours for bacteria and 48 hours for yeast and mold, we can able to say the sensitivity of the system is even one live cell, if it is present in the pot, we can able to identify. So the time to result is, let's say, this CSA protocol, it is from 15 days, you can release your product in 2 days. Whereas if it's as per IS standard, instead of 7 days, you can release them within 2 days. This will ensure, like, yes, say for example, like as I mentioned, this is a rapid system. This is also well established and also used by numerous global manufacturers. Even at India, we have a good installed base for juice manufacturers. That's why I come next for the ADX approach for the fruit juice. So the major challenge in fruit juice is that the risk of fermentation, yes, it will change organoleptic properties. And next thing is that if there is any fault happening, if there is any mishap during the processing, it is going to cost you a large scrap, right? And next, the consumer acceptance is going to deteriorate, which will put the brand image at the stake. So in this case, again, the same platform can be utilized where you can do the direct count of pure raw material, let's say your pulp. So you can check your pulp, you can enumerate without any incubation, and you can say like, okay, whether can I wait for some time, or I can club the raw materials together and I can able to process it. Or the initial count of the bacteria is very high, I need to process it very immediately. So that information we can able to obtain. And yes, during your, let's say you have some mix, you are going to do some processing, again you can do. So before, let's say for example, before packaging, you can able to count. That's why you say it's a parametric criteria for you. Instead of depending on the finished testing, you can test at each and every step of your manufacturing to ensure like there is no deviation in any of the protocol that we follow through the processing. That's why we say in the day zero, I mean the day of manufacturing, we can able to detect if there is any contamination or if there is any mishaps during the processing. That's why it is kind of a tool for you to give a prediction on the early one, right? Once the manufacturing is done, again you can able to incubate the sample, and again the sensitivity of the pack is going to be 1 CFU. Next is in terms of meat. So for meat, actually, we have a concept named Poultry 360. That also starts from the approach of, let's say, from the farm level, farm of the flock, till the finished product, and also it reaches the consumer. So it's a full approach. Actually, here you can see like sample preparation. Again, here you are clubbing microbiology and molecular biology together, along with the AGDX approach, where we do root cause analysis, where we can able to map the pathogen in the industry, where we can able to map where the spoilage organism which is present in the industry, with the help of metagenomics and microbiome. So one important thing is that, let's say for example, in our industry, let's say that in the food industry there is a pathogen outbreak. So ultimately what we'll do, we'll just screen for the presence of bacteria, bacteritis. So we found out it's a Listeria monocytogenes, let's say for example. So the ultimatum is that we will be checking like whether it is the whether it is a contamination from the product as well, or it is the environmental contamination. So that is something which we will think. But what we have to do is that we can take one step ahead, and we can able to find, or we can find what particular strain is the contaminant, because the sources may vary for each and every strain. Let's say let's say Listeria monocytogenes, the source can be the same for Listeria monocytogenes only. But if I go to the strain level, the source of contamination will be different. Let's say for example, it can be at the raw milk area, raw material area. That may be one strain, and one will be in the, let's say, the later stage of processing. If you found the raw material strain in the processing area, it means that there is a mobile event which happened, which took the contamination from the raw material area till the processing area. That's the thing. So if we do the strain level, we can able to identify, let's say, which Listeria monocytogenes is it, or which strain of Listeria monocytogenes it is. So it will give me a kind of an information like, okay, whether it is really a contamination or it is a contamination from my lab. That's the first thing. Next, I can able to identify like who is this, let's say, who is this uninvited guest to my factory. If I have the existing, if I have the historic data, I can able to identify like, okay, this is something which is in my factory, and I know that this may happen. So I have the, let's say, for example, I have the plan to eradicate it or overcome it in terms of cleaning or in terms of adding some extra interventions into it, right? That's why we say like only the detection of pathogen is not enough. You have to go one step ahead, and you can ensure like, okay, if you have the, let's say, the historic data, let's say if conventionally you are doing microbiology testing with traditional methods, that historic data will be a base for us to evaluate which category of strain is present and at the which source it is present. Now let's take an example of, let's say, the timeline of risk. As I said, like pathogen is present in the industry. So we found that pathogen is present in the industry, right? So ultimately what we'll do, we'll stop the production. So again, it is going to be a cost to us, right? So what will happen? The analyst will check like, okay, whether I have seen this, the one which I already said, whether we have seen this before, whether it is a contamination or whether it is already available, whether it's already present in my factory, or whether it is linked to certain different raw material which I have procured, not the routine one which I have procured something new. So we'll destroy the batch, we'll do the cleaning. So after cleaning, we are going for the next round of production, and we found that okay, there is no problem now. So cleaning ensured that the particular contamination is removed from the factory, and now it is safe. But again, in the week third, we found that again there is a contamination in the product. So now again he will destroy the product. I mean, he will stop the batch, he will destroy the product, he will do the cleaning. But what if after the cleaning, again the next production batch also has the same contamination? Whether he will do the routine step. If he is doing the routine step, again he is making the same mistake. That's why I say like, even not me, I mean, as a solution provider, we suggest is that we have to have the historic data, or we need to know what is really inside my factory. So there, whole genome sequencing can be a tool, because that will help us to give a highest level of information that is required, because it will able to help me to understand what is my present level and what will be my future contaminations also, right? So here actually we have with WGS, actually with the genome sequencing, we can able to have an insight on what's the real scenario which happening. That's where actually we came up with the protocol. I mean, we came up with a solution which is GeneUp, where it is beyond RT-PCR, where you can able to type, where you can do the sequencing of your contamination. Let's say what contamination it is. So with your historic data which is already established, we can feed it into the platform, and we can able to link which source or which particular area that contamination actually came from. So let's say with GeneUp typer, if in the first day or the first production when we got the contamination, we can able to identify where it exactly happened. And this software also gives an insight like which particular strain it is and what kind of treatment that we can do to eradicate it, right? So that gives you a kind of information, and we can able to eradicate it out, and we can able to have a full track of event of happening, like what is the past record and what is the current scenario, right? This is something that I have just gave information. Like as a routine, we do the testing of, let's say here I have highlighted for Listeria and Salmonella. So once we have the positive, we will stop the production, and we have to take the decision immediately, because time is the key, and we need to identify the root cause, what is the exact thing, right? So with GeneUp typer, with the new approach, you can able to understand like, okay, what is the thing and what I need to do and where it is present. So I will have the full answer to the questions that needs to be understood, right? So I can able to take an action within an hour. I need not wait for, let's say, weeks or days to do it. Within an hour, I know like what is a particular organism. So I can able to take a decision fast. So from the routine route, I am coming to investigation tool. So I know what is a particular strain. So I can able to map it. So I can able to understand what exactly it is. Let's say I have something which is very new, which is not present in my historic data, which is something new. I can able to identify it, and I can link it with the pathogen mapping. So it is going to become as a continuous improvement process for me also to know if at the future, if I have the same kind of incident or event happening, I can able to understand where exactly is the thing. And as I said, like we can able to build a database on our own, like what is the existing microbiota flora that I have in my factory. So that's why we say with typer, you know, like the result in a faster way, and you know like where it comes from, you know actually what it is, and we can say you know what to do. That's the thing. So from discovery, I mean to say from detection of a pathogen or it's a spoiler, you can able to do the precise identification of what exactly it is, and also you can able to map it with your industry. So that's why you say like, let's say like these are the steps that we can do. Let's say for example, pathogen we can detect, we can able to identify from which particular part of the cluster it is, and we can able to map. In terms of spoiler, I will first identify which particular spoilage organism it is. I will understand the metagenomics of the spoiler, because spoiler is very crucial because we are going to enumerate it. So it is very important for us to identify the metagenomics, the flora, the entire microbial flora where this particular spoilage organism will grow, and we will do the spoiler mapping. That's why I simply say like with augmented diagnostic approach, we really know what exactly we are doing and what exactly we can do. That's the key. So this is the last slide actually. So here what I want to let's say like brief or summarize is that we actually bring value into the entire operation through this augmented diagnostics approach. It is not like the finished product testing. It is from starting from your raw material, let's say the one which comes to your factory or which is new to your factory, your in-process samples, your environmental monitoring samples, your finished products, even if your retained samples, anything is there. So we can able to access the full data, and we can the generated data can be put into a kind of a sequence in such a way like we know what's actually happening within our industry or within the premise, right? So this will also give a tool. I mean, this will also give a upper hand to the quality management, saying that okay, I have a spoilage organism or I have the pathogen in my factory. So my ultimatum is to first detect, first it's to acknowledge, yes, I know there is a contamination. First acknowledge, then you detect, then it is a part of your continuous improvement process, because we cannot say like my factory is free from any pathogenous spoil. One way or the other, it is going to be there. So it is for us to be a part of the continuous improvement process to say like, okay, I have a contamination, I acknowledged it, I detected it. This is a part of my process. So moving forward in my CC, maybe I will revise my critical control point, or I will increase or decrease the limits that needs to be done. So this gives me a tool for me to understand, right? And this is going to keep on happening. That's why we say like we bring value into the total food industry operation. That's it from my end. Thank you. Yeah.
So thank you so much, Ram. Ladies and gentlemen, big round of applause to Mr. Ram Mohan Mutharasu, product specialist, food safety and quality from bioMérieux. Ram, I would like to ask you to kindly be on stage for a couple of more minutes while I invite on stage Mr. Sanjay Pandey. Mr. Sanjay Pandey from SP Food and Nutrition Consultants. Can we have Mr. Pandey here on the stage, please? Mr. Sanjay Pandey, ladies and gentlemen, from SP Food and Nutrition Consultants, to kindly do the honors of felicitating our honorable speaker. Big round of applause again, ladies and gentlemen, Mr. Ram Mohan Mutharasu on that wonderful presentation on addressing food safety challenges, augmented diagnostics approach from our partner bioMérieux.